Introducing Buffon's needle problem. Suppose we have a floor made of parallel strips of wood, each the same width. What's more, the width between the parallel lines is just equal to the length of the needle we have. If we drop a needle onto the floor, what is the probability that the needle will lie across a line between two strips? Next are two experiments of this problem. In this one, imagine a process like this. You draw some parallel lines, drop a bunch of needles, mark the needles lie across the line, add them up, divided it by the total number of needles you drop. Then you got an experimental probability. In 1000 needles trial, we got an experimental probability of 0.61, which is really close to the theoretical probability, 0.63. Facing this figure, you may ask, where does it come from? What does it mean? Actually, it is the ratio of 2 over pi. And now, you're gonna have another question. What is pi doing here? I just dropped some needles, and it has nothing to do with circles. But as Grant used to say, pi is very much tied to circle. So if you see it show up, there will be a path somewhere in the massive interconnected web of mathematics, leading you back to circle in geometry. So today, we're not gonna use calculus to solve this. All you need is some basic knowledge of geometry and some imagination. First, let's think about what factor gonna have an impact on outcome. See? First is the position of the needles. What's more, the direction gonna be another factor. The direction gonna influence the outcome as well. And we could break down position a little bit more. We could break it into horizontal position and vertical position. Now, if I tell you one of them are innocent, that is, it has nothing to do with the result, could you pick it up? Yeah, it's vertical position. Think of a needle like this. It does not lie across a line. And no matter what vertical position it lands, it does not lie across a line. And for a needle like this, lie across a line, no matter what vertical position it lands, it will cross the line. One across the line, will cross the line. So vertical position could die. And horizontal position and direction will definitely influence the outcome. Now, if we want to deal with these two factors both at once, we are fucked up. The easier way is we fix them one by one. Now, let's think about for a needle with particular direction, how different horizontal positions gonna influence the outcome. Let's say for a needle with direction 60 degree, what is the probability that it will lie across the line? First, let's list all the 60-degree needles. Remember, the vertical distance doesn't matter, so we just need to list all possible horizontal positions. And of them, the green needles are the ones lie across the line. I have marked them up in green colors. For a needle with 60-degree direction, to calculate the probability of lying across the line, what you're gonna do is count the number of green needles and divide it by the number of all needles we list. And as we can see, there are patterns. The ratio of the whole gonna be the same with the ratio of each part. So we just need to focus on one single part of it. You know, actually the number of needles gonna be countless, but we could use the lens to represent the magnitude of the number. So the number of all needles gonna be that big. And the number of across needles gonna be that big. The probability we want to calculate gonna be across over all, which is across over width. As we mentioned before, the width is equal to the length of the needle. So the probability gonna be across over length. Now, what is cross? Is you're gonna draw a triangle like this, and the cross gonna be the baseline of it. See the dark green line? That will represent the number of cross needles. And that is a super important conclusion we're gonna use later. Because it's so important, let me say it again. For a needle with particular direction, if you want to calculate the probability of it lying across the line, what you need to do is draw a red triangle like this and calculate the base green line over the length of the needles. With this, we could solve any particular direction needles. And now, what is the overall probability? The answer is the mean of these particular probabilities. See, we get different directions, so we get different probabilities. And the overall probability is the mean of these different probabilities. Now, let's list all possible directions. It's gonna be like this, all possible directions. And imagine what it will be like if we link them end to end. If you are a little bit lack of imagination, hope this animation could help. You see what is coming? Yes, it's a circle. They're gonna form a circle. And maybe that's where pi come from. And each direction of needle has its own probability, like P1, P2, P3, and so on. And at the end, there will be like Pn-1 and Pn. The overall probability is to calculate the mean of these probabilities, which is add them up and divided by n. Remember the conclusion we drew before? To know the exact value of P2, you need to draw a red triangle like this and calculate the green line over the length of needle. And to know the value of P3, you need to draw a triangle like this and calculate the green line over the length of the needle. And it is the same for the rest of them. Now, let's update the equation on the right. We could express P1, P2, and so on in this way, green over length. And since they have the same denominator, length of needle, we could add them up like this. And then we could put length downward. We get this. Now let's think, what is n times length? Actually, it's gonna be the sum of length of all needles, which you can see in this picture as the perimeter of the circle. So n times length gonna be double pi r. And finally, we're gonna figure out what is the sum of all these green lines. Look at the first three green lines. We could add the first two together by moving them to the same horizontal line, and use the same method to add the third one. And actually, we could add all of them in this way. So we're gonna keep moving, keep moving, keep moving, and keep adding, and keep adding. And you're gonna receive a pretty picture. The sum of all these green lines. The result gonna be these two green long lines. As you can see, one of them is equal to the diameter of the circle, which is double r. So two of them gonna equals to 2 times 2r. After a few simplification, we get this, 2 over pi. And that is where pi come from. And that is the simple answer of Buffon's needle problem. Now, please let me end my video with 2 quotes. A change in perspective is worth 80 IQ points. Good artists copy, great artists do.